Hi everyone, this is Sunny Kumar from IIT BHU and welcome to my channel Code with Sunny, and today I am going to discuss the problem intersection of two linked lists, and the index number is 160 and the problem is of easy type of Leetcode. Okay, so let's jump directly into the problem statement without wasting our time. So in this problem we have to write a program to find the node at which intersection of two singly linked list begins. So for example, suppose this is our linked list, that is linked list A is represented by A1, A2, C1, C2, C3, and linked list B is going to be represented by B1, B2, B3 and followed by C1, C2, C3. So there are two linked lists, but there is an intersection point, that is the point which is common to the both the linked list, and also the point is the very first point, that is the first point of the common intersection, that is it is going to be C1 as you can see here. Now how we are going to do this problem in most efficient way? So let's move further, let's move to the constraints. So if we can be benefited using this also or not. Each value on the linked list is going to lie between 1 up to 10 power 9, and your code should preferably run in O of n time and use only O of 1 memory. So we have our code should be memory efficient also. So how we are going to do this problem? Let's move further. So let's understand this also, what is actually given in this question. We have been given two linked lists and we have to find the intersection point of the two linked lists if it exists. Our node values ranges from 1 to 10 power 9. So let's take advantage of this, okay? And what should be our goal? Our code must run in O of n time and O of 1 extra space. And what is the prerequisite to solve these problems? That is to solve this easy problem. So we must know the traversal in the linked list, that is how we are going to traverse in the linked list, also the basic maths. So let's move on to the example to understand this problem. Suppose we have been given two linked lists represented by 4, 1, 8, 4, 5 and another linked list 5, 6, 1 and then again 8, 4, 5. So this is the intersection point, that is you can see I am going to highlight this. Okay, let's choose some specific color. So this is our intersection point, that is 8. How we are going to find this? Note that our node values, that is our node value is going to lie between 1 to 10 power 9. So can we take advantage of this? Yes, we can take advantage of this. What should be the advantage? Note that these values are always positive. So what I am going to do is I am going to traverse one of the linked lists. Let's say I am going to traverse this linked list and make all the nodes in this path, that is all the node values of this linked list as its negative. Let's me denote. I am going to, if I am going to traverse in my first linked list, let's say linked list A, I am going to make its nodes value, that is -4, -1, and this one also -8, and this one also -4, and this one also -5. So if I'm going to make all these nodes values as negative, so now what should be our approach to find this intersection point? Now you can easily see, if I'm going to traverse in my new linked list, so let me change this color. So if I'm going to traverse in my linked list B, so on traversing this linked list, whenever we find the first point at which the node value is going to be negative, that is you can see -8, then we can claim that yes, we have found my intersection point. Note that -4 and -5 are also the also lies in the path of this linked list, that is linked list B, and which is also negative, but I need the very first point because that will be our intersection point. So we can easily claim that this is our what intersection point. So I am going to traverse in my linked list B, and whenever we find the value of the node being negative, we can claim that this node's address is our answer. So I'm going to return this node's address, that is node with value absolute value 8. Now note that I need to convert all these values which I have made negative to again positive, so that linked list structure may not be modified according to the problem. So this is our basic idea. So what is our basic idea? Make all the node values of one of the linked list as its negative and traverse the second linked list, and whenever we found the first occurrence where the node's value is going to be negative, this would be our intersection point. What about if we haven't found any node's value being negative? So there will not be an intersection point because the two nodes are independent of each other. That is, there will not be a common point, common node that is going to connect these two nodes, connect these two linked list. Okay, so this is our basic idea. So let's move on to the approach, how we are going to perform this implementation. So traverse in one of the linked list and say linked list A, I'm going to do that, and mark all its nodes values as negative. Traverse in the linked list B also and check whenever we will find a node with negative value, this will be our intersection point. That is the very first node when we find the node with negative value. Now make all the node values of the linked list A as positive again, because I need to keep the same linked list structure as per question. So our time complexity would be O of n and our space complexity will be O of n. Why? We are not using any extra space. And let me write this also, that is our time complexity will remain as O of n because we are traversing every node, or you can say we are going to traverse every node one time. Also I am going to write here modification is O of max of n comma m, where nm are the length of the linked list respectively. Okay, so let's move on to the implementation part. So I've already run my code. You can see runtime beats are 99.93 percentage of CPP submissions. Now let's move further to the code. Now what I have done is I have taken a pointer head and assigned it as the head of the head A list. Now I am going to traverse in my linked list A and make all its values, that is nodes value, as its negative, that is negative of head A of val. And now if I have made all the first linked list values as negative, now I am going to traverse in my linked list B, and whenever I have found the value that is negative and as answer as null, this means that I have found my first occurrence where the value of my current node is going to be negative. I am going to assign my answer as head, that is, this should be our intersection point anyhow. And if we find again the value being negative, note that answer doesn't remain as null because we have already found the intersection point. So this if condition will never be executed once we get a intersection point. So again I'm going to traverse in this linked list B and find the suitable answer as intersection point. Now note that I need to keep the same linked list structure. So I'm going to again traverse in my first linked list and I'm going to make all its value as its previous by taking the absolute values of the nodes. So this is our method, and finally I'm going to return the answer. So the code is very faster. So if you have any doubts, do not forget to mention in the comment section of the video, and the link to the code is mentioned in the description section of the video. And I will ask the viewers to like this video, share this video, and do subscribe to my YouTube channel for latest updates. Thank you for watching this video.